So we're in the practical part now of uh, the practical part of chapter 3. And let's go and see what's going on here. We'll share the screen first. Then we'll see examples of what we are going to say in this part. So we have on chapter 3, usually your logistic exam and the quizzes will include a practical part and theoretical part, theoretical and practical. So we will talk now about the practical parts of chapter 3. Here we have the task time. Task time, this is a law, is the available production time required by required outputs rates. Required by required outputs rates. Let's, as example, we have here 6 basic steps for the modeling: identifying the process, steps required, draw the precedence diagram, determine task time for the line, compute the theoretical minimum number, use a decision rule to assign the workstations, to have the number of workstations, evaluate the performance of the proposed line. Those are our 6 tips which we use for layout decision, for the layout decision. So this may be theoretical, but the most important thing is this model. Cycle time, maximum amount of time spent in any one of the workstations. Ideal time, IT is the ideal time, means the W actual, which is mean the actual number of workstations, actual numbers of workstations, uh, minus T, which is the plural or the sum of the whole time. So present ideal time will be the IT, which we get it from here. This is the IT divided by the WCT. Efficiency delay 100% minus P1, which is percent ideal time. So ED, efficient delay, equals 100% minus the what we get from this equation. 100% minus P1. Like if I tell you as example, a probability that you go is 30%, then what is the probability that you don't go to this place is 100% minus 30%, then it equals 70%. Let's see an example about this. Here are the workstations. So we have as example, look at this. I will go back and forth here so that you understand it. And actually, I won't get it to you like this. I might tell you to draw the flow of the stations, the diagram of the stations, and I will give you some calculus ready made. So you will apply the law in this case. Okay, task A, this is the start. The time of task A is 15 seconds. Let's go see here. This is task A. We put it in a square like this, task A, and we put down the 15 seconds. Okay, let's go for task B. Task B is 26 seconds. Look at this. Task B is 26 seconds. But if there is any operation before it, yes, text A is before it. So let's go here. I will come here and draw a square and put B and put the 26 seconds, B, 26 seconds. I will draw it, B and 26 seconds. But he said that there is something preceding, which is A. So I will make an arrow. I will draw an arrow from A to B. That arrow tell me that B is exceeded by A or A exceed B. Look at this. Here B, 26 seconds. The immediate, the one before it exactly, immediate exactly is A. So A is here before B. So I draw B 26 seconds. Then I put A 15 seconds. Okay. Then C is 15. C is 15 seconds. But C is also proceed. The one before C, the previous one before C is A. Then here I will make a new square and write down C and the new square, a square, write down C, and C is 15 seconds. Then I will draw the C 15 seconds. Then what is the preceding one? What is the preceding one or the one previously? The one before it is A, the stage before it. As example, A is the wood. B is cutting the wood. C is cutting the wood into very small pieces. Or let's see, B is operation and C is another operation, but both of them are, A is per request for them. A is per request. Okay, so okay, so A is before B and A is before C. Let's say as example, you want to go to the second floor. So this is the first floor. You will make two stairwell. You will make stairwell B and you will make a stairwell C. But before you make B and C two stairwells, you have first to make stairwell A. Okay? Okay. And you will draw on each station. You will draw on each station like this 26, 25, 15, 15. You will draw the time on every station. Let's go to D. D is 32. Okay, I will draw a square and right inside it or beside it 32 seconds. The time of this stage D, time of stage D is 32 seconds. That's fine. Yeah, but before D, I have B and C. I have B and C. That means here is, I will draw the D and I will take arrow from the B and arrow from, because D is exceeded by B and C. D is exceeded by B and C. So I will draw D, then from there I will draw A, B, and C. Let me just explain it back. I will do it and explain it on the board. Okay, so this is now, I will do it right on the board also. When I finish it, I will draw it again on the board. Okay, let us now see this. After this, we made A and B and C and D. The stage E, like you see, is 25 seconds, but I have to watch out. Is there any phases before stage D? Okay, before stage E? Yes, stage D before E. So here I will make E 25 seconds, and I know that D is before E, so I will draw a line in between D and E. So when you read it, you will see it stage E 25 seconds and preceded by D. D was before it. D was before it. It was 32 seconds. Okay. Now, let's go to the stage F. Stage F is 15 seconds. Okay, let's see here. F, 15 seconds. What are you expecting? Without looking, I will see, without looking at the schedule, that it is preceded by or this stage E. So when I see here in the schedule, see F is preceded by stage E. That's fine. Okay, okay, that's fine. That's fine. It is so now F and G and H the same thing, preceded by E. F, G, H, preceded by E. But I will write the time of each one in front of it, like F15, um, F15, G18, H10. F, I will write 15 here, G18 here, and H10 here. Then stage I. Stage I will cost 22 seconds. But the stages which are before this are F and G and H. Like as example, if you are making shirt, then this is the sleeve, this is the back of the shirt, this is the front of the shirt. They all will go together to one place, which will stitch them all together, So this stage is called I. Stage I is 22 seconds, preceded by F and G and H. Look at this. Look at this. Stage I is preceded by F and G and H, and it is 22 seconds. Finally, we have the stage J. It is 24 seconds. Then I will draw a square and put J and write 24 seconds, and I will see from where it's coming. If there is anything before J, anything before J? Yes, I before J here, I before J. Then I will make a line from J to I to J. Let me do it on the board in front of you guys. Then we will see what does it mean. Like I will show it to you and okay. So I have first stage A 15 seconds, then I will draw like this A, and write 15 seconds. Okay. Then I have after this B 26 seconds, and before it is A. Then here is B, here is B. B stage is 26 seconds, 26 seconds, exceeded by stage A. Here is the exceed by stage A here. Okay, how about C? 15 second also. C is 15 second. This is C. It's 15 second, and it's exceeded by stage A. Exceeded by stage A. Then D, I have D, 32 seconds, but before it B and C. Then I have D here, D here. It's how many? How many D? 32 seconds. 32 seconds exceeded by B and C. Here we go. Exceeded by B and C. Then I have after this E, 25 seconds exceeded by D. Then this is stage E. Stage E is 25 seconds. 25 seconds. Exceeded by stage D. Then it comes from stage D like this. Okay. Then after that, I have stage F, 15 seconds. F, here is F, 15 seconds, 15 seconds, exceeded by the stage E, is stage E. Okay, F. Let's move because F is 3. So we'll make it up here as example because we have from E, 3 are coming. F, this is 15 seconds. We have also G, 18 exceeded by E. We have G, 18 exceeded by E. So E is here as well. E is here as well. Then we have also H, the stage H. H is, how much is H? 10. 10. And also exceeded by E. The stage H is exceeded by E. 10. Then I, 22. I, here is I, 22. And I is exceeded by 3, the 3 of them, by F and G and H. So I is 22, exceeded by F and G and H. Then finally, I have J. Finally, I have J. J. This is I, and this is J. And the stage J is 24 seconds. 24 seconds. And J is exceeded by I. Exceeded by I. And this is how I draw it. This is how I draw the stations and the stops and how I collect. So from the example here now, from this example now, which I showed you here on the board, I want you, now we can collect the total time. Yes, we can collect the total time. Let's go to the screen back share and see the total time. When I collect the total time, it will give me all this together, 15, 26 plus 15 plus 32 plus 25 plus 15. So all the time worked will be the total. When you make it with the calculator, it will be 202. Okay? Okay. Now, we'll move into another thing. Okay. Now we'll go to a new point in our works today. We made the stations, we made everything. We're done here, and this is the same one on the board behind you. Now we'll take, it's just equations and you apply in the equations. That's it. He gave me already that the total, the available production time is 28,800 seconds. The available, which where I know it, he will give it to me in the example. He will tell me in the example, like he said here as example, he will say that the available time for working is like this, blah, 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 is about like this. He will give you in the example 28,800. I will give you this available production time. Okay. Required outputs rates 500 units per day. Because of what? He said $500, 500 units in 8 hours. This is in the example. Giving. It's giving. You just, what you will do is apply the law. That's it. You will substitute with the numbers which is given in the example with you on the law. So this will give you 800 divided by 500, it's 28,800 seconds divided by 500 units for 8 hours working. You will find it in the example. You will find it in the example here. He will tell you it's a 500 units in 8 hours working. Then this will come. The task time will be 57 when you divide it in each other, 57.6 seconds. Okay. Then the W minimum, we have it before, which will be the total time, 202 seconds. This is the 202 seconds, which we got, 202 seconds, divided by the number which you had from equation 1, which is 57.6, and that will give you 3.51. 3.51, this number, 3.51. But this number is representing the minimum of the station. W is working minimum stations, means how many stations like these stations I will have, how many stations like those stations, like these ones, how many. So I will say, because I'm dividing the work into stations, that means I will have 3.51 stations. You have to round it because there is no station. Station means a place for the production, a unit that the production stop in or go from. A station, you can say, you can resemble a station with a room or a place like attending place area. Okay, this is the station. As example here, F and G and H are three stations. Will wait till the stage or the phase E is done. Then E will give to F, and E will give to G, and E will give to H. Then, like I told you, let's say F is the sleeves of this shirt, G is the front of this shirt, H is the back of this shirt. Then I will stitch all of them together. So I will wait till F finish and G finish and H finish, and they will send it to them. Let's say 200 shirts. Then they will finish all the 200 shirts here. Okay. Then after that, I is the packing the shirt, put it in package. J is the package. J will wait till stage I is done. And this is the idea of the stations and the follow of the stations itself in the logistics system. Okay. So what you will do is the task time equals available production time. You will have with knowing that the available production time is 28.800 seconds. And the required output rate, while the required out, this all given in the example. This is all given in the example. So 500 units per day. Then what you will calculate, you will calculate the task time, you'll divide them by each other, time available production time by the required output. Then it will give you 57.6. This is the task time. Okay. If I have a task time of 57.6 and I have the total work will take 202 seconds, from where I knew I collected all this 15 seconds, 26 seconds, 15 seconds, plus 25 seconds, plus 15 seconds, plus 18 seconds, plus 10 seconds, plus 22 seconds, plus 24 seconds. Those all will come to and you can also get it from the sum here. It's the same. The same number. It's 202 when you collect it. So this is the only number which you will not have in the example. The other numbers, all you will have it. Okay. But watch out, because 500 units per day of work, like I told you. If I tell you they work for 8 hours and each hour they produce 30 units, then it will be 240 for the day. 30 by 8. Okay. So take care of this point. Others, everything will be clear for you. Okay. Then this will be here the task time, the waiting, the number of working stations will be 3.50. Nothing is called working. If I say 3 persons and 51.51 person, no, 3.51 means three persons and half a man, 2 legs and 2 hands. Same thing for the stations. 1 station or no station. So I rounded 3.51. I will make it 4 workstations, and that's it. You will have another examples, but we will have a very easy example for you for this idea. When you come to see now, what we will do, we will divide this work, this chat here, we will divide it into 4 slides. Number one, stage one, A and B and C. Stage B is D and E. Stage C or 3, F and G and H. And the final stage will be I and J. Again, the stage A and B and C. The stage D will be D and E. The stage 3 will be F and G and H. And stage 4 will be I and J. Okay. There is a connection, I mean, a meeting points. How I know them? Because of the meeting points of spreading points. This is separating between each stage and the other. A meeting point for the arrows to come, or separation points where the arrows goes. This you can know from that stage. So meeting points come here. This means the end of this stage. And separating arrows coming out, then this is means another stage. Okay. So here also meeting, this is the end of the stage, and after this there is arrows going this another stage. Okay. So each stage of this, we will calculate the points of it. We will have to calculate the points of it, like this, like here. As example, the workstation 1, A and B and C. 15 seconds, A and B and C. These points, A and B and C. Okay? All of them comes to 56 seconds. 15, oh, C, again. A and B and C. 15 and 26 plus 26 plus 15. Those will come to, how much? 56 seconds. Same thing I will do for the stage 2, D and E. It will be 32 seconds plus 25 seconds. Look at this. Look at this. D and E. 32 seconds and 25 seconds, which come to 57 seconds. Then we'll go to workstation 3, which continue off G and F and H. Here we go. Here we go. F and G and H. They are 15 and 18 and 10 seconds, right? So all this will come to 43 seconds. When you collect them, 18 plus 15 plus 10, they are 43 seconds. Then stage 4, 22 seconds plus 24 seconds. This is the last thing, I and J. Those are 46 seconds. Now, we'll look for the longest one of them. The longest one of them. We have which one? 46, 43, 57, 56. I guess it's 57 because it's the largest number here is 57. The largest number for the stations is 57. That's fine. Great. Now I want to calculate something is called the ideal time. The ideal time. We will give it the symbols. We give the symbols like the symbols is the letters, like the initials. Take the initials. I for ideal, T for time, equals working stations, the number of the working stations, multiplied by CT actual, means the longest stage. The stage which take more seconds. We have 4 stages now. The longest one is 57 seconds. This one is the 57 seconds. Let us see where. This one, 50 seconds, which is station 2, because it takes D and E, take very long time, 32 seconds and 25 seconds. Those all come to 57 seconds. That's fine. That's very fine. Then I will multiply them. What I multiplied, 4. 4, here is the 4. 4 is the number of stations, because the result of the equations, the first equations, give me 3.51, which is 4. We rounded 4. This 4, I will take it, multiplied by the longest station, which is 57. Then, like here, 4 by 57 second minus what? The 202, which in the starting table minus the 202. The 202 seconds here of the starting table. This one, which is time in. For all the phases, for all this chart, the plural, all you add, 15 plus 26 plus 15 plus 32 plus 25 plus 15 plus 18 plus 10 plus 22 plus 24, it will give you 202. Okay, so what we did again, we have four stages, four stations. We got it from phase one, it's 3.51. Like here, when we calculated 3.51, we said there is nothing is called 3.51 stations. There must be four stations. Okay, we took the four stations to get the ideal time. We have now divided our work into four stops or four collections or four groups. Group working station A, and working station B, and working station C or 3, and working station 4. Okay, because we said it's around four stations. From the example here, it came 1, 2, 3, 4. And also, if you didn't know by this way, there is an experience one which said whenever there is arrows collecting or spreading, this is the end of a station and start of another station. Okay, so we have one station, this one, A and B and C. We have second station, D and E. We have third station, which is F and G and H. We have the fourth station, which is I and J. Okay, we will collect, we will add, make addition for every one of them. 15 plus 26 plus 15 will give me a number like this way. We did it here. 15 second, B 26, C 15, they are 56. Then same thing for station number 2, D and E together, then for number 3, then for number 4. Then I will take the largest number of the stations. I will take the largest number of them. The largest number of them is 57 of workstation 2 because the numbers are very huge. 57. Then for getting the ideal time, to get the ideal time, I will take the working stations actual, which is four stations. I will multiply by CT, which is the largest number of the four station, which is 57 seconds, minus the one which I collected of all the phases together. It will give me 26 seconds. Okay, then to get percentile idle time, the percentage, I don't need to say it because it's like you will divide the ideal time by the whole time of the, which we got here, 4 by 57, 22.8. So you will multiply 26 seconds by 228 and multiply by 100. This will give you 11.4. Okay, so if this is considered like deficiency, we consider it like deficiency, then the efficiency delay will be 100% minus. If I tell you you might study this night 11.4%, then how much you won't study the percentage? 100% minus 11.4% will give you the rest of it. Means 100% minus P1, which we get present idle time. So it will be, or 1 minus P1, 1 minus 11.4%, 100%, or 1 minus 11.4%. It will give you 88.6. If I get it to you, I will get it more easier because I will try to get the numbers for you in an easy way. Just remember the rounding. Remember here, the rounding is very important for you. Yeah. Just I want you to remember back. I want you back to remember. I want you to remember back that it's another example. Now we'll say again, we divided our work. Again, I will repeat this feedback. From the start, the available time 28 seconds, 28,800. This is giving in the example, divided by 500 units per day, and this is also given by the example. It gave me 57.6 seconds for the task time. Okay. Okay. Then I will say the number of working station, W means working stations minimum, will be 202 seconds divided by this number. It will give me 3.51.4 workstation. Then I will have 4 workstations. Okay. My work will be divided into 4 workstations, like I did in the board. This is the first A and B and C, D and E as the second workstation, F and G and H is the third, I and J is the fourth workstation. Then I will put each number of seconds in front of them. This is given in the example. Task A was 15 seconds, task B was 26 seconds, task C was 15 seconds. All will come to 56 seconds. Same thing which I did for working station A. One I will do for 2, I will do for 3, I will do for 4. Then I will take the largest number of them, which is now the first one 56, the second one 57, the third one 43, the fourth one is 46. The largest number of them is 57. Then this will be for me. Uh, Now look at here at the stations itself. This is a station A and B and C, D and E another station, F and G and H station 3, J, I and J station 4. I know it from two things. I know it from the result of phase 1, which I rounded and I made it 4 stations, which was 3.51. And I know it also because there is from the experience, the arrows, the direction of the arrows. If the arrows is splitting from a point and ending another point, that means it's an end of a stage. So here, this is an end of stage 1. This is the start of stage 2. And this is the end of splitting, start of the H3, and end of the splitting, start of phase 4 from here, and then is nothing after 4. Okay. Now, we said to get the ideal time means working stations, which working stations are 4 working stations after rounding them, multiplied by 57 seconds. Okay, 57 seconds minus 202. Okay, what is the 57? We said the 57, the largest one, the CT which we got, minus 202, it will give me 26 seconds. Then I will get the ideal time, the percent of the ideal time. It will be 26 seconds by the 228 seconds. Okay, so this will give me the percentage 11.4%. Okay, okay. How about if I want the efficient delay is 100% minus P1. Also, I want you to notice that the W actual CT is the 228, which is this 4 multiplied by 57. What is the 57? Okay, is the largest station time, 57. Okay, here we go. And this is the end of the practical part of chapter 3. Thank you. Hello, my dear students. This is chapter 3. I will just go to it first, then I will start discuss it in details. Like any other specifications here, we need to make share for the screen. And here we go. This is chapter 3, and this is the main objectives. We'll come to it while we are working on the chapter, because I will come slow bit by bit after this. This is the start of it. I will show what I'm going to say, that after that I will go in details. The manufacturing process, first type of the manufacturing process is the production line. Production line is manufacturing process used to produce a narrow range of standard items with identical or highly similar designs. Remember the biscuits, the chocolates, it's all standard. When you press the machine button, it will work, it will give production, it won't stop producing. It's very difficult to change in the specifications of or customize the product based on the client's orders or the customer's orders is very impossible. You can't do this here. Okay. The manufacturing process needs high volume because whenever you start to press the machine, It gives you a high volume of production, like the biscuits, like the chocolates, like I'm saying. And it's not flexible, it's inflexible, it's not flexible, because you cannot change in the product style or anything regarding the product. Second way of process of production is called continuous flow process. It's also a kind of, you can say it's a production line. It's also standardized products using high tightly linked pace sequence of steps. There are steps closely resembles to the very close to the production line, like we said. Form product usually cannot be broken into discrete units. Examples include, as example, yarns, fabrics, food products, and chemical products such as oil and gas. Okay, you can stop the production if it is going. It looks like a line of production. Here, it show me the ways of production line and continuous flow process. It show me both of them, how they looks like. Here we go. It needs, of course, equipments and people are highly specialized and arranged sequentially. Sequentially means phase one gives to phase two gives to phase three gives to phase four. So they are arranged based on this, on each sequence, and it's always good for the high volume of production. It's always good for the high volume of production. The second kind or the third kind is called job shop. This is a very customized. As example, like the furniture. If you want if you want to do furniture, but you need a specific final touch or final things in your furniture. Okay, you need a bed with this, you need that, you need or long big bed, small bed, queen beds, double bed, single bed. So it depends on a type of manufacturing process used to make a wide variety of highly customized, look at this, customized products in quantities as small as one. Characterized by general purpose equipment and broadly skilled worker. There must be skilled workers working on it. There must be a skilled workers. The main emphasis is meeting a customer's requirements. So here, because it's customized, why we customize it? Or the meaning of customizing, just to be um, based on the customer wants. What do the customer want? Okay, so the customer needs a specification, a real specification, or a design change in the design, or whatever change. So we do it for him here in the job shop. Product design is not standardized, of course. Standardized is in the production line, not here. Typically follow as functional layout. That's fine. Examples include, look at this, custom furniture, specialized used goods, used by manufacturer and restoration. And so all these kinds of, okay. This is the job shop. Each stage is looks like it's separated than the other stages because in each stage of this you might add some specific things which the customer wants. That's why, as example, the beds are together, the chairs are together, whatever. So in this case, you are doing what you are doing, just doing the specifications of the beds. Might need long bed, big bed, single bed, queen bed, whatever, chairs, small chair, big chair, and all are done from the wood and based on the customer's wants. And in the same time, it's very flexible because it depends on the customer wants and it's very customized. It's arranged by function, and um, it's like a sequential also requirement. One can change dramatically from one job to the next. Low volume of production. It's not like the production line, high volume. No, here it's a low volume of production. Uh, the other kind is called batch manufacturing, a type of manufacturing process where items are moved through the different manufacturing steps in groups or batches. So here, you are not moving a product by a product. No, you are moving a batch of products together, all of them moving to another stage. A package, a batch, many products together are moving. Fit between job ship and lines And production lines, he means production lines in terms of production volume and flexibility. So it is in between both of them. The batch manufacturing is between the production line and is between the job shop. It's neither customized nor standardized. It's between both of them. Are the most common type of manufacturing process. Okay, so this is um, it's very flexible, and it can reduce the cost of making groups of similar things. I can reduce the cost of the similar products here by using this way. Fixed position layout, it's like the planes, like doing the planes. When you see the manufacturing of planes, it takes this figure here because things, buildings, the construction, the product here is very heavy, you cannot move it. So all the workers come to feed it with the inputs. Okay, the building there, the workers, the bricks layers put the bricks, the drywall, put the drywall in the plane. If the plane, the aeroplane, they put the chairs, they put the engines, they put the wings, they put the cabin, they put everything, cockpit, everything is there. So in all the product there cannot move because it's very heavy, and you feed it with all the inputs. It's also like the ship building. It's the same thing. The ship cannot move. It's in its place, and you feed with its parts. Construction projects and building homes. How about the hybrid manufacturing process? It gather more than one because actually it gather more than one of those types of production. It's not only one, but it gather more than one of them, like matching centers, group technology, and flexible manufacturing systems as well. Manufacturing process, group technology work cell, we have here, and the manufacturing process, it's a group that works on work cells. Equipment and personnel are dedicated to the production of a product family. Okay, cellular layouts, resources are arranged according to the dominant flow of activities from product for the product family. The most important one of them is the 3D actually, because 3D is nowadays application. It has been shown up after the third wave and G4 and G5 and the computers, advanced use of the computers in designing and this and that. So it's called three-dimension printing. It's a kind of additive manufacturing process that creates a physical object from a digital design. Digital model is turned into solid three-dimensional physical object by adding material layer by layer. It allows manufacturing to occur when and where the item is needed, which can be real advantage when time is the essence. Okay, and I'm looking for short of time. So 3D is using the advantage of technologies in producing. Okay, manufacturing process, like you see here. Here is the threads. The threads had been changed into fabrics, and from the fabrics it's stitched, and it's done like a plover or materials or whatever. Here it shows me the manufacturing process, the product process matrix. Here the types which we talk about: the job, the job shop, and the low volume batch, high volume batch, and production line, the four medias of types of production. And here we go through the volume of the production, which here is very low, then modulate, then high, then higher, and see the relationship between them. Actually, it's not a point of importance. Here is very important points for me also to know. Make to stock MTS, product that requires no customization. In the MTS, there is no customization. It's only standardized. It's only like the biscuits. So we call it MTS, means no customization. Where standardized means no customization. A simple to order, we have that's partly customized only at the very end. at the very end. Like as example, if you buy a car, Rolls-Royce car, so you need only the doorknobs to be gold. This is at the end of the production, before the car comes out. So the doorknobs are gold. This is called ATO. Make to order, MTO. This is the initials. Make, M, T, TO, order O. Products that are used standard components but have customer specific final configuration of those components. It's a standardized, but there is a final configuration based on what the customer needs. Engineer to order, products are designed and produced from the start. So from the start itself, you customize it, you change in the design from the start of producing, not at the end, like this one, like at the very end, like the ATO. The ETO is different, the opposite of the ATO. This and this are entirely different. Usually the customer's needs or required. Here, like you see the ETO in the start of the design, then MTO in the middle, ATO maybe the middle or more than the middle, MTS like the doorknobs of the Rolls-Royce at the end or before the end of production. Uh, we will stop here, like on this slide 24 for chapter 3, and we will complete. And now I will start to talk about them. I talk about them in figures, and I will talk about them each one alone with examples. So I will go back like in details in the next part. Okay. Thank you so much. You have a very great time. We'll be back. We will be back. Welcome back, my dear students. This is chapter 3. We'll start chapter 3 now. And we'll just move on to chapter 3. Process, choice, and layout decisions in manufacturing and service. Manufacturing means the production. In the production, what we will do, describe the characteristics of the 5 classic types of manufacturing process. The 5 classic types, this is very important, the 5 classic types of manufacturing process. Discuss how different manufacturing process choice support different markets requirements. Explain how different manufacturing process can be linked through together via the supply chain, and describe the critical role of customization in manufacturing. Describe the critical role of customization in manufacturing as well. So, including the degree and the point of customization, as well as upstream versus downstream activities. This also point of which we have to talk about. So we'll discuss the 3 dimensions that differentiate services from one another. Service package, customizing this and that. And we will position a service on a conceptual model. And we'll explain how different services process support different markets requirements. And we'll check about the product based layout. And this will appear, I mean, now it's very stiff words, but it will be easy when we come to discuss it. So here, what is the manufacturing, or what we'll talk about the manufacturing? And services are very important. Why? Why manufacturing is important? They tend to be expensive and far-reaching. To first, because second, because process decisions deserve extra attention because different processes have different strengths and weakness. Each process of production is having its own strengths and strength and weakness points. Some processes are particularly good at supporting a wide variety of goods and services, okay? While others are better at providing standardized products. So, based on, as example, demand, based on demand production, what we call it, mass production, the kind of production itself, it's affected by a lot of factors. And each company manufacturing will decide which model or which kind of production process it will use. So managers must carefully consider the strengths and weakness of different process and make sure that the process they choose best support their overall business. Okay, so they must make sure that it supports their overall business. Selecting maybe this sentence is important. Selecting an effective process means much more just choosing the right equipments, manufacturing, and also include people, facilitation. So everything must be must be in a very high quality. Everything. It's not only the process of manufacturing, but a lot of points. So manufacturing is a complete system. You have to care about the quality in each system, in each part of it. Different manufacturing processes have different strength and weakness. Some are best suited to making small numbers of customized products, while others excel at reducing large volumes of standard items. Okay. The manufacture of a particular item might require many different types of manufacturing process. Okay. Spread over multiple sites and organizations in the supply chain. The manufacturer of a particular item might require many different types of manufacturing process spread over multiple sites and organization in the supply chain. The manufacturer of a particular item might require many different types of manufacture. So we have many types of manufacturing process. And I will show you now when we come to talk about it, the types. So some products they may collect all this together, especially when the product is very complicated. In that case, more than one way of process will work together to finish the final product or to make the final product. Okay. Manufacturing process. Questions asked about what are the physical requirements of the company's product? So what we are producing, how similar to one another are products company makes. So is it similar to each other or with differences? As example, Rolls-Royce is having cars with regular doors, like other cars with the knobs are gold. Okay, so this difference in the types of the two kind of products, what does it affect? How it will affect on the work? What are the company's production volume? What how we will use, like we will use mass production or just a little bit few products of this item or whatever. Where in the value chain does customization takes place? Okay, so how we will customize our product? Which part of the chain of process there will be a customized product, or all the products will be customized? Product based layout. This is the first thing. A type of layout where resources are arranged sequentially, according to the steps. Sequentially means one by one, phase by phase, according to the steps required to make a product. Okay, this is a product based layout. We'll see a diagram for it now. Functional layout, a type of layout where resources are physically grouped by function. So, as example, if you go to um, a factory that they make shirts like these shirts, so you will find the cutting the fabrics in one area, then stitching the sleeves in one area, then stitching the front and the back of the shirt in another area, then assembling all the shirt together with the collar and everything in another area. This we call it physically grouped by function. Uh, Continuous flow process, production line. We will know what the meaning of production line means. The line in where the product is located in, and there is feeding for this product from everywhere till the product comes to the at the end it will be finished good. Like the car, like the cars as examples, the automobiles, when they are on a product line, they move, and there will be a value added in each stage. They add to it something till it's be ended at the end of the line. It will be done. Batch manufacturing, job, shop, and fixed position layout. Fixed position layout, and this is also another point. Fixed position layout, everything in its place, and you bring for it the elements of production or the tools or whatever you will apply on this product, we will provide to this product in its own place, in a fixed place. Manufacturing process, production line. Let's see this. You will start to talk about each of them. Production line, a type of manufacturing process used to produce a narrow range of standard items. Look at this, a narrow range of standard items with identical or similar things. They are all similar to each other. So we use a production line. We use production line for this. Follows a product-based layout. Steps are usually linked by some system that moves the item from one step to the next step. So steps are usually linked by some system that moves the item from one step to the next step. That's fine. Okay. Items typically move through the production line. So they move in the production line at a predetermined pace. So they move from a point to another point. The product is moved from a point to another point, etc. Suitable for high volume production of products when we have a high volume of productions, characterized by similar design attributes. So all those make something we call it the product line. When the your products are similar, when the design is similar for all the products, when it is typically like uh, so this way we use the product line. Need high volume, and also to have a product line you need a high volume of production, like a big amount of the outputs is required here. Specialized equipments and labor are inflexible with regards to items that do not fit the design characteristics of the production line. Also, this kind of lines, because you press the button, then you will have hundreds of thousands of products which are all similar to each other. Okay, you cannot customize here. Customizing here is very hard. You cannot customize the product because it's all similar to each other. Machines are working and finish. As example, the biscuits, the chocolate bars, the chocolate, the biscuits, all those are are work based on product line because you can't stop production. Once you press the button, hundreds of thousands of units will be done, will be produced. So in that case, you cannot customize. Very hard to customize. So it is, as long as you cannot customize it, then it is not flexible. It is inflexible. How about the continuous flow process? A type of manufacturing, this is another kind, a type of manufacturing process that products highly standardized products using a tightly linked paced sequence of steps. So one step, we finish this, then it goes to phase two or the second step, then the product will goes to phase three, then the product will go to phase four, till it's ended at the end of the line. Closely resembles the production line process. Form of products usually cannot be broken into discrete units. Okay, we cannot break it into discrete units. It's continuous. Like you do something, you start something, you have to end it. Examples include yarn and fabrics. The fabrics like this, fabrics, food products, and chemical products such as oil and gas. Once you started, you cannot stop. And you cannot stop to produce another product because it's only on this line. They produce only this kind of product. Okay, manufacturing process. What is the manufacturing process? This is the product line and continuous flow process. So look at this. The first one, product-based layout. Equipment and people are highly specialized because they are very highly specialized. Okay, and arranged sequentially according to the steps required to make a product or a product family. A product family means, like as example, if you have many kinds of biscuits or if you have many kinds of chocolates, we call it a product family. Okay. Production is often paced, best suited to high volume production of standardized products. Like we said before, the standardized products means you cannot change or customize it because once you press on the button, hundreds of thousands of units will come to the end of this product. Okay, so this is about the product line and continuous flow process. Phases: phase one, phase two, phase three, phase four, till the product is ended. Every phase till the product is ended at the end of the line. Okay. Manufacturing process, job shop. A type of manufacturing process used to make a wide variety of high customized products. High customized, this time highly customized. Okay, products in quantities as small as one. So here you are talking about a customized product characterized by general purpose. There are general purpose equipments and broadly skilled workers. Okay, and broadly skilled workers. Okay. For example of those, the furniture, like you see here. Some people will ask for a furniture with some specifications. Others will ask for other specifications. So it must be customized based on the order of the customer, what the customer wants. So this kind is called job shop, a type of manufacturing used to make a wide variety of highly customized products in quantities as small as one. Of course, it's not like the product line. In the product line, you have mass production. You cannot stop manufacturing until you produce hundreds of thousands of units. But here, no. The production is limited here. In the job shop, the production is limited. Main emphasis is meeting a customer's unique requirements because I'm trying to see the customer's requirements. Product design is not standardized, like we said, not standardized, not a biscuits, it's a furniture, not chocolates, it's furniture. So everyone needs something different. Everyone is having a mood in this kind of furniture or whatever, so he needs something different. Typically flow as a functional layout. Examples include custom furniture, specialized used by manufacturer, and restoration, and the machines also from machines tools and refurbishing work, which is so all those kinds. I want you just to see the custom furnitures and some parts of the machines as well, like uh, machines which used to produce, like for production. This is also customized, like those machines which is dealing with the metals parts. So this is a kind of, okay, a kind of manufacturing. Here is the manufacturing process in the chop shop. Look at this: stage, 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 stage. See, thing goes out from one stage, go to the second, go third, then finally it goes. General purpose equipment and broadly skilled people. Yeah, because in each stage of this they appear to be disconnected. You have to add for them something will make them unique than the other units, so it's not a standardized units. Functional layouts: work areas are arranged by function. uh, like as example, this area is for cutting the wood in the furniture. This is for configuring wood. Okay, this area for making beds, chairs, and tables from the wood. and here is the assembling line. So best suited for low volume production, because in this kind job shop, the, the production volume is very low. So be very careful in this area. Okay. Highly flexible, yes, but not very efficient because of too much flexible. So it's not very efficient because a lot of hands are working at the same time in different types, and because there is no standardization. What about the batch manufacturing? A type of manufacturing process where items are moved through the different manufacturing steps in groups or batches. So here the items are moving in groups or in batches. Is not one item by one item, but group of items all together. Uh, Fits between job shop and line. So it's between both of them. It's in between them, between the first two things, the line and the job shop, which we've talked previously about. In terms of production volume and flexibility, and strikes a balance between the flexibility. So it's like a balance between the other previous two kinds, which is production line and shop job. Okay, are the most common type of manufacturing process. This is the most common type. So it's very famous. The frequency of it is very high. It's everywhere. The sequence of steps is not as tightly linked as production line. So like we said, it is in between the production line and the shop. Flexible manufacturing system, highly automated. It's using automizations, mechatronics, electronics, this and that. Mechatronics, like I'm using the electronics just to control the mechanical parts of the machines, like the robot and these things. Is highly automated. Batch process that can reduce the cost of making groups similar products. Okay, so it's in between them. The fourth kind is fourth position layout, a type of manufacturing. This is number four now. Number four, a type of manufacturing which what? That process in which the position of the product is fixed. Or like the planes as example, like the planes, like the buildings, like the construction. You see the building and everyone is adding something into the building. We call it fixed position layout. Planes, when you see the plane, it's stopped in one place, located in one place. And all the feeding for the several parts, feeding of the plane to put inputs into the plane while the plane is parking in one spot, in one point. It does not move. Used in industries, materials, equipments, and workers are transported to and from the product. To and from the product. So everything is moved from. So you are moving. Workers are transported to and from the product. So exactly remember the plane. When they are making, manufacturing a plane, aeroplane, it's stopped in one place and everyone is feeding this plane. Okay. Used in industries where the products are very bulky, massive, heavy. Something is very heavy that cannot move on a line. It has to stop in one area. Construction, as example, the examples like the buildings or whatever. Heavy or movement is problematic. You cannot move it. As long as you cannot move it, the production line, then in that case, the only thing you need is to keep it in its place and you feed it from everywhere. Examples include shipbuilding, like building the ships, construction projects, and traditional home building, and the home building as well. Manufacturing process, hybrid manufacturing process, a term referring to a manufacturing process that seeks to make a combine of the characteristics and hence advantages of more than one of the classic process. Then more than one of the classic process. more than one of the things. So hybrid manufacturing, this hybrid manufacturing from hybrid even means a mixture of what we talked about before, the production line, the shop, okay, all this together, we make from it hybrids. So it's including, we're all trying to avoid the mistakes and drawbacks and to enhance the advantages of each type of them. Like you see as example, there is no flexibility in the production in a production line, but you find flexibility in the shop job. Okay, but it's like every one of them is having its own privilege, advantage, and disadvantage as well. So it's covered by the next one or the other one or the other type of production. Okay, in hybrid seems to combine characteristics and hence advantages of more than one of classic process. Machine centers, machining centers, group technology, flexible manufacturing system. So it has disadvantages altogether. The manufacturing process looks like this. Group technology work cell. Here group technology, here's group technology. Equipments and personals are dedicated to the production of product family. Product family together like a mix of products. Cellular layouts. Resources are physically arranged according to the dominant flow of activities for the product family. How they are, how they are flow, then we will arrange our equipments based on this. Manufacturing process, 3D printing, and additive manufacturing process. This is a very recent one. It depends on the three dimensions that creates a physical object from a digital design. Okay, you will tell me this is old. No, of course, it's very recent because it is related to the computer designs and it's a very recent one, the three dimensions. A digital model is turned into a solid three-dimensional physical object by adding material layer by layer. It allows manufacturing to occur when and where the item is needed, which can be a real advantage when time is of the essence or of shipping an item from a plant to its final destination is difficult. So that's where we do the 3D. So manufacturing process, this is linking process together to make a sweater as example. From the fabrics, the spinning, it was just a thread. Into weaving you made the fabric. Then from the fabric you cut it and make the plover and sew it and make the plover. Okay, so the manufacturing process, the product process metrics, those are job shop, low volume batch, high volume batch, production line. Okay, and here we have one of every low production volumes, small of machine production, and medium of large production volumes, according to the volume of production here. And this is highly volume of production. Okay, you can see here as example, you can see here, each one of them is having its space, like it's the space of it. So this is a part. We have also four levels of customization. Customizing means based on the order or the demand of the client. We have make to stock, product that require no customization because you will put it in stock. You will put it in the stores, the wholesale. Assemble to order means based on the order you have, you assemble your own, okay, your own products that are customized only at the very end of the manufacturing process. Assemble to order, but it is at the end of the manufacturing process. Make to order, products that use standard components but have customer specific final configuration of those components. The customer needs some specific things, but it's also at the end stages. not in the very first stages of the production, no, at the end stages of the production. Engineer to order, products are designed, this one, products are designed and produced from the start to meet unusual customer needs or requirements. Here, engineer to order, the customization is made from the start, while make to order, the customization is made almost at the end, not at the start, at the end uh, of the order. So make to order at the final, but engineer to order, the amendments and the change in the design is made at the early start. This is product customization where the supply chain. Okay, here is the ETO in the design itself, MTO in the, as example, the design, the sourcing materials, the fabrication, the assembling, the distribution, assembling and finishing as example. So MTO is done here, ATO is done here, MTS. And we have here make to stock. This is the MTS, ATO, MTO, ETO. You apply it on 1, 2, 3, 4. Okay, ETO in the early in the design, MTO in the middle, you can make it in the middle, ATO before the final, and MTS at the final touch. Like as example, if you are making suits, main suits, okay, I want the buttons to be blue, or I want the sleeves to have blue red buttons, or whatever, or I want only like. But here in the start itself, the design change comes from the start. Okay, here only final touch. What is the law of the variability? What we call, what's the meaning of the law of variability? The greater the random variability, either demanded of the process or inherent in the process itself or in the item processed. Okay, the greater the random variability. Okay, the greater the random variability either demanded of the process. Okay, the law is relevant to customization because completing upstream activities offline helps isolate these activities from the variability caused by either the timing or the unique requirements of individual customers. But what will happen for the customization itself? If it is early, then flexibility is response to unique customers' needs will be greater. Okay, like as exactly like the cancer, when you discover it first, early, you can get to the treatment. Like lead times to the customer will tend to be longer. Okay, products will tend to be more costly. The products will be more costly in this case. Okay, great. Okay, now let's see.